Hello students, I welcome you all to my channel and today our topic is MCQs on the chapter Periodic Classification of Elements. So here I have covered some important multiple choice questions on the chapter Periodic Classification of Element. Hope this video is going to help you in doing well in your board examination. So let's start with the first question. Considering the elements boron, aluminium, magnesium and potassium, the correct order of metallic character is, means you have to find out the option having the correct order of metallic character. Children, I am not going to explain you what is metallic character, what is non-metallic character and all that stuff in this video. This video is meant just to a trick will help you in finding the metallic character. See here, an atom with a greater size will be more metallic in character, and at the same time an atom having a smaller size will be less metallic in character. If you know this point, then easily you can find which atom is more metallic in nature and which is less. So for that we need to write the electronic configuration of the elements here. Like boron we are having with atomic number 5. So we first write the electronic configuration of them. 1s2, 2s2, 2p1. Children, if you doesn't know how to write the electronic configuration, I have made a video how to write the electronic configuration. Do watch that, then that will help you in understanding this video. So anyhow, moving to next one, there's aluminium with the atomic number 13. Now let's write the electronic configuration of it. 1s2, 2s2, 2p6, 3s2, 3p1. So first we will write the electronic configuration of all the elements. Magnesium with the atomic number 12 has a configuration of 1s2, 2s2, 2p6 and 3s2. And last element we have got here potassium with atomic number 19 and the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So for that you need to know the electronic configuration. Once you done with the electronic configuration, I'll tell you which will be greater and which will be smaller in size. An element having the highest number of shells, that will be greater in size. Means potassium having the 4 shell has a greater atomic size, means option D is going to be correct here because it has the greater atomic size here. Still, now after that these two elements magnesium and aluminium has 3 shells. If you come across elements having same number of shell, then which will be smaller and which will be greater? How do you find that? Know this. See here, and if you find 2 or more elements having same orbit, yes, then an element with smaller atomic number will be greater in size. So first greater is potassium, then it comes magnesium, and obviously now comes the turn of aluminium, and boron with the least number of orbits comes at last. Means option D is going to be the correct answer for this question. So just try to understand the trick or the method to find or to approach such questions. Okay, hope you got the trick in doing such questions. Now moving on to the next question, children. Here you can see element with atomic number 8 belongs to which block? Yes, you know that there are the 4 block elements in the periodic table: S, P, D and F block. How to find the block? See here, let us say X is an element with the atomic number 8. We need to write the electronic configuration first, that is 1s2, 2s2, 2p4. Okay, after that you see at last where the electrons are entering. If it is P, then write it is a P block element. Okay, was quite easy. but important because such questions are expected in the exam. Just watch the full video so that you can get the complete idea like how and what kind of questions will arise here. Now moving to the third question here, atom of which among the following element is greater in size? In the first question only I have told you how to find an atom having greater size. So still we write the electronic configuration first, that is lithium with the electronic configuration of 1s2, 2s1. Sodium with atomic number 11 has a configuration of 1s2, 2s2, 2p6, 3s1. Okay, it is 3s1. Now magnesium with atomic number 12 has a configuration of 1s2, 2s2, 2p6 and 3s2. Lastly, we have a calcium here with atomic number 20. Let's write configuration here: 2p6, 3s2, 3p6, 4s2. See, I told you an atom with highest number of shell will be greater in size, that is calcium having the 4 shells will be greater in size. So the option D is the right option here. Okay, children, hope you are following the things here. Electronic configuration is very important in this chapter. If you doesn't know, really you will struggle a lot in this chapter. So anyhow, moving on to the next question here. In a trade of three elements A, B and C, the atomic mass of A 7, B is 23. Find the atomic mass of third element, that is C. So you know all very well that is the Dobernius law of trade. That is B is equals to, mathematically it can be written as A plus C by 2. Now in the question what you can see here, C they have asked, so we can rearrange it for C. C is equals to 2B minus A. Now 2, B is nothing but here 23 minus A value is here 7. So now it is 2 into 23, that is 46, minus 7, that gives you 39. Means option A is right here. Okay, this was on the law of trade. Hope everybody knows it. This is how you will have to approach towards such questions. Now look at the second question. Okay, next question is here. The most electronegative element among the following. See, again I'll tell you the trick how to find an element which is most electronegative. Atom having smaller size will be most electronegative. Again, writing electronic configuration will help you in finding the size. Atomic number of oxygen is 8. So we'll write the configuration here. 2p4. Then now nitrogen with the atomic number 7. Children, you all must know the element with their atomic numbers minimum up to 30. Yes, 2p3. And fluorine with atomic number 9 and configuration 1 is 2, 2 is 2, 2p5, and carbon with atomic number 6, configuration 1 is 2, 2 is 2, 2p2. Now how you will find which of these is a smaller an atom, more electronegative it will be. See here, you can see all the elements here have the equal number of shells. Which will be greater in that case? An element with greater atomic number. If you find all the atoms have same number of shells, then remember an element with greater atomic number will be smaller in size. Okay, so according to that, fluorine is going to be the correct option here. Yes, if you find an element with greater different orbits, then in that case element having a smallest orbit, last orbit will be smaller in size and most electronegative. So these are the things Okay, that will make you little faster other than others in the examination, which is most required one. Okay, anyhow, here the next question you can see here, which is on your screen. Valency of an element with the atomic number 9. I think you all have learned how to find the valency. I'll tell you, if the last shell has one electron, then its valency will also be 1. If the last shell has two electrons, then its valency will be equal to it, that is 2. If the last shell, which is also known as valence shell, if it has 3 electrons in it, then its valency will be 3. If it has 4 electrons, then the valency will be 4 itself. But if it has a last, if the last orbit or the valence shell has 5 electron, then you know what you will do. This 5 should be subtracted from 8. Okay, from 8 you have to subtract it, then you will get the valency. Similarly, if the valence shell has a 6 electron, again you need to subtract it from 8. If it has 7, again subtract it from 8. If it has 8, again you need to subtract it from 8. This is the method to find the valency. So now let us approach towards this question. See, an element X with the atomic number 9. So we'll find its valency 1s2, 2s2, 2p5. Means here last shell you can see it has 7 electron. 8 minus 7, that is 1. So the valency is 1. Means option D is correct here. Hope you all are getting the way how to do with all these questions. Pause and watch it carefully so that you understand the trick or the method here, which is very important in the MCQ type of questions. Okay, whole year you have been prepared for the descriptive type of question, but for the MCQ type of question objective you should have a different approach. Okay, otherwise you will waste lot of time in that. So moving to the next question here, the atomic number of the element X, let us say it is 20. In the modern periodic table, this element belongs to the period. Means you have to find the period of the element with the atomic number, an element with atomic number 20. So we'll write the configuration again. See, a configuration is the tool. Yes, otherwise you cannot do anything here. Yes, 3p6 4s2. So this is the configuration of it. And now how you will find the period of that? See here, the period is equals to the valence shell, last shell. Last shell tells about its period. Means this element belongs to the 4th period of the modern periodic table. Okay, hope you all have got it. Now after this, our next question is, in the modern periodic table, as we move down the group, the atomic size of elements is it increases due to the addition of orbits. Yes, it increases due to the addition of orbits. You remember this way that atomic size decreases across the period and increases down the group. Okay, it increases down the group. Next question you see here, which among the following pair of element belongs to the same group? So in this question you will learn how to find the group and which pair of these 4 belongs to the same group. See here, first go with the lithium here with atomic number 3 and magnesium atomic number 12. Let us find out, are they belonging to the same group or not? So again the configuration will help us here. Magnesium electronic configuration 1s2, 2s2, 2p6, 3s2. After writing the configuration, I'll tell you how to find the group. Look at the valence shell. If they have equal number of electrons, then the group will be same. Here it belongs to the group number 1. Okay, group is 1, and here it belongs to the second group. Means first option is not going to be the correct here. Let's try with the second. Carbon with the atomic number 6 and silicon with atomic number 14. So let's write the configuration here. Yes, how do you find? We'll see the electrons in the last shell, that's a valence shell. The configuration of silicon is 1s2, 2s2, 2p6, 3s2, 3p2, 3p2. You can see the valence shell has equal number of electron, means option B is right here. Remember, this is how you will do it, children. Okay, these are the some tricks will help you in the exam to crack such questions in a blink of time. Okay, now moving further, another last one or two question we are last question we have here. Okay, most electropositive element among the following. Children, see how in the first question itself I told you how to find an element which is most electropositive. An atom is which is having a greater size will be more electropositive. Okay, so again write the configuration. Yes, find out which is greater, which is smaller. Yes, 1s2, 2s2, 2p6, 2p6, 3s1. This is the configuration of sodium. Calcium with the 20 atomic number has the configuration of this. Okay, 3s2, 3p6 and 4s2. Now potassium with atomic number 19 and the configuration 1s2, 2s2, 2p6, 3s2, 3p, 3p6, 4s1. And last one, aluminium with the atomic number 13. Let me write the configuration here: 1s2, 2s2, 2p6, 3s2, 3p1. So now see here, more electropositive element will be that which has a greater atomic size. Greater atomic size means you will see the valence shell, the highest shell number, that is these two have the highest shell number out of these four, that is fourth one. Now between these two there is the answer here. How do you find that? See here, if you come across and some elements having same number of shells, valence shells, then which will be greater, you know, an element with lower atomic mass, that is potassium it is. So potassium is the answer of this question. Hope these videos help you little bit in enhancing your performance and making you little faster in such applied level questions from the topic periodic classification of element. If you like this video, do like, share and subscribe to my channel. Thank you.